projects. In this video, we are going to explain about the project title Disease and Drug Recommendation System using Machine Learning and Deep Learning. Introduction. The project focuses on creating a disease and drug recommendation system using machine learning and deep learning techniques, aiming to leverage advanced technology for improved healthcare decision making. It aims to tackle the challenges encountered by healthcare professionals in disease diagnosis and drug selection, providing them with an intelligent system that can assist in making informed treatment decisions. Traditional methods rely on manual analysis of patient data and medical literature, which is time consuming, error prone, and inefficient in handling large data sets. Consequently, these methods often fail to deliver personalized treatment recommendations, hindering optimal patient care. The proposed system employs machine learning and deep learning algorithms to automate the analysis of patient data. By utilizing predictive modeling and recommendation algorithms, it can generate personalized treatment plans tailored to individual patients, thereby overcoming the limitations of traditional manual methods. Machine learning and deep learning offer robust tools for extracting insights from complex healthcare data. Their ability to handle large data sets and discern intricate patterns enables more accurate disease diagnosis and personalized treatment recommendations, ultimately improving patient outcomes and enhancing healthcare delivery. Objective. The project focuses on developing a software system that leverages machine learning and deep learning techniques to assist healthcare professionals in making decisions related to disease diagnosis and drug selection. By integrating advanced algorithms with healthcare data, the system aims to provide personalized recommendations, ultimately leading to better patient outcomes. This includes suggesting appropriate treatments based on individual patient characteristics and medical histories. The project utilizes a combination of machine learning and deep learning algorithms, including random forest, k nearest neighbor, support vector machine, gradient boosting, voting classifier, and CNN. Each algorithm offers unique strengths and capabilities, allowing for comprehensive analysis of healthcare data. For instance, random forest and gradient boosting excel in handling structured data, while CNN is adept at processing medical images. By integrating multiple algorithms, the system can achieve more accurate predictions and recommendations. The project involves providing symptom information to the system, which then generates personalized diet plans and drug recommendations. This process takes into account individual patient needs, treatment responses, and medical history to tailor recommendations accordingly. By considering various factors such as dietary restrictions, medication interactions, and treatment efficacy, the system ensures that recommendations are optimized for each patient. Algorithms employed in the project undergo rigorous evaluation using performance metrics such as accuracy, precision recall, and FINSCO. These metrics provide insights into the effectiveness of each algorithm in accurately predicting disease diagnosis and recommending suitable treatments. By evaluating algorithm performance, the project can identify the most effective approaches and refine the disease and drug recommendation system for optimal results. The disease and drug recommendation system benefits both healthcare professionals and patients by improving healthcare decisions and patient outcomes. Healthcare professionals gain access to valuable insights and recommendations that assist in diagnosis, treatment selection, and patient management. Patients receive personalized recommendations tailored to their specific needs and treatment responses, leading to more effective healthcare interventions and improved overall health outcomes. Software and hardware requirements. Hardware requirements of the project are operating system of Windows, processor of 5 and above, RAM of 8 GB and above, hard disk of 25 GB and above. Software requirements of the project are application is Anaconda, primary language is Python, front-end framework is Flask, back-end framework is Jupyter Notebook, database is SQLite 3, front-end technologies used in the project are HTML, CSS, JavaScript, and Bootstrap 4. Working modules or flow of work. To implement this project, we have designed the following modules. The first module is importing libraries. This module involves importing various libraries and dependencies required for the project. Libraries like Pandas and NumPy are used for data manipulation and pre-processing, scikit-learn for machine learning algorithms, TensorFlow and Keras for deep learning models, Flask for web development. These libraries provide essential functionalities needed throughout the project. Importing dataset. In this module, the dataset containing relevant healthcare data is imported into the project environment. This dataset includes information such as patient demographics, medical history, symptoms, treatments, drug responses, and more. The dataset serves as the foundation for developing and training machine learning and deep learning models. Exploratory data analysis. EDA involves analyzing and exploring the dataset to gain insights into its structure, distribution, relationship, and potential patterns. Techniques such as summary statistics, correlation analysis, and data visualization are used to understand the data better. EDA helps in identifying any anomalies or inconsistencies in the dataset and informs subsequent data pre-processing steps. Data visualization. This module focuses on visually representing the data through plots, charts, and graphs. Data visualization techniques such as histograms, scatter plots, and box plots are used to visualize the distribution of data, relationships between variables, and any trends or patterns present in the dataset. Data visualization aids in gaining a more intuitive understanding of the data and helps in making informed decisions during the modeling process. Text cleaning. Text cleaning involves pre-processing textual data to remove noise and irrelevant information. This includes tasks such as removing punctuation, special characters, stop words, and non-alphanumeric characters. Text cleaning ensures that the text data is standardized and free from any inconsistencies before further processing. Tokenization. Tokenization is the process of splitting textual data into smaller units called tokens. These tokens can be words, phrases, or sentences depending on the level of granularity required. Tokenization facilitates the conversion of text data into a format suitable for machine learning algorithms to process, such as bag of words or word embeddings. Training and building the model. In this module, machine learning and deep learning models are trained using the pre-processed dataset. The models are trained to predict disease diagnosis and recommend appropriate treatment options based on the input data. Performance comparison. After training the models, their performance is evaluated using appropriate evaluation metrics such as accuracy, precision recall, and FN score. This step involves comparing the effectiveness of different algorithms and selecting the best performing model for deployment. Performance comparison helps in determining which model is more suitable for making accurate predictions and recommendations. Flask framework with SQLite for sign up and sign in. This module involves setting up a web application using the Flask framework and integrating a SQLite database for user authentication, sign up, and sign in. Flask provides tools and libraries for building web applications, while SQLite is a lightweight relational database management system suitable for small scale applications. The sign up and sign in functionality allows users to create accounts and log in to access the disease and drug recommendation system. User gives input. In this module, the user provides input data such as symptoms or medical history through the front-end interface of the web application. The input data is collected and pre-processed to ensure compatibility with the trained machine learning or deep learning model for prediction. The given input is pre-processed for prediction. Trained model is used for prediction. The pre-processed input data is fed into the trained machine learning or deep learning model for prediction. The model predicts disease diagnosis and recommends appropriate treatment options based on the input provided by the user. The prediction process utilizes the learned patterns and relationships captured by the model during training. Final outcome is displayed through front end. Finally, the predicted outcome, such as the diagnosed disease and recommended treatment plan, is displayed to the user through the front end interface of the web application. The user can view the results and take appropriate actions based on the recommendations provided by the system. The front-end interface provides an interactive and user-friendly experience for accessing and interpreting the model predictions. Algorithms used to implement this project, we have designed the following algorithms. The first algorithm is random forest. Random forest is an ensemble learning technique that constructs multiple decision trees during training and outputs the mode of the classes classification or the average prediction regression of the individual trees. It is robust to overfitting and works well with both categorical and numerical data. In the context of the disease and drug recommendation system, random forest is used to predict disease diagnosis and recommend suitable treatment options based on patient data. Coming to the second algorithm, which is KNN, K nearest neighbor. KNN is a simple yet effective supervised learning algorithm used for classification and regression tasks. It works by finding the K nearest data points in the feature space and classifying or regressing based on the majority class or average value of the neighbors. KNN is non-parametric and lazy learning, meaning it does not require model training and makes predictions based on the entire data set. In the disease and drug recommendation system, KNN is used for disease classification and drug recommendation based on similarity to other patients. SVM, Support Vector Machine. SVM is a powerful supervised learning algorithm used for classification and regression tasks. It works by finding the hyperplane that best separates the classes in the feature space. SVM can handle linear and non-linear data separation using different kernel functions. It is effective in high dimensional spaces and is memory efficient. In the disease and drug recommendation system, SVM is used for disease classification and drug recommendation based on feature vectors derived from patient data. Gradient boosting. Gradient boosting is an ensemble learning technique that builds a series of weak learners, typically decision trees, sequentially. Each tree corrects the errors made by the previous one, leading to a strong learner with improved predictive performance. Gradient boosting is robust to overfitting and can handle complex interactions between features. In the disease and drug recommendation system, gradient boosting is used to predict disease diagnosis and recommend treatments based on patient data. Voting classifier. Voting classifier is an ensemble learning technique that combines multiple individual classifiers and aggregates the predictions by majority voting classification or averaging regression. It can improve predictive performance by leveraging the strengths of different algorithms. In the disease and drug recommendation system, a voting classifier is constructed using various algorithms such as KNN, K nearest neighbor, and support vector classifier to make collective predictions for disease diagnosis and drug recommendation. CNN, Convolutional Neural Network. CNN is a deep learning architecture used for image classification and regression tasks. It consists of convolutional layers followed by pooling layers to extract hierarchical features from input images. CNNs are effective in capturing spatial dependencies and are robust to translation, rotation, and scale variations. In the disease and drug recommendation system, CNN is employed for analyzing medical images to assist in disease diagnosis and treatment recommendation. Comparison graphs. Comparison graphs offer a visual breakdown of how our models perform across essential evaluation metrics. Models are compared with the evaluation metrics accuracy, precision, recall, and FN score. This is the accuracy comparison graph. Here on the x-axis, we have the algorithm name, and on the y-axis, we have the accuracy score. Accuracy is a measure of the overall correctness of a classification model. It calculates the ratio of correctly predicted instances, both true positive and true negative, to the total number of instances. This is precision comparison graph. On the x-axis, we have algorithm name, and on the y-axis, we have precision score. Precision is a metric that assesses the accuracy of positive predictions made by the model. It calculates the ratio of true positives, correctly predicted positive instances, to the total number of positive predictions. True positives plus false positives. This is recall comparison graph. Here on the x-axis, we have the algorithm name, and on the y-axis, we have recall score. Recall, also known as sensitivity or true positive rate, measures the model's ability to correctly identify all relevant instances in the dataset. It calculates the ratio of true positives to the total number of actual positive instances, true positives plus false negatives. This is FN comparison graph. Here on the x-axis, we have algorithm name, and on the y-axis, we have FN score. F1 score is the harmonic mean of precision and recall. It is a balanced measure that considers both false positives and false negatives. It is calculated as 2 times the product of precision and recall divided by the sum of precision and recall. It provides a single metric that balances precision and recall, making it useful when we want to consider both false positives and false negatives in the evaluation. The algorithm which is performing best in all the performance metrics is used for prediction. Execution. To execute this project, first we need to open the code folder which contains the project source code files. This is the code folder. This is the static folder. This folder consists of files related to CSS, JavaScript, and Bootstrap. This is the templates folder. This folder contains all the HTML pages used in the project. It includes files like index.html, about.html, and more, which represent different pages of the website. This is app.py file. This .py file contains the information related to front-end logic. It includes code written in Python that handles server-side operations such as processing user requests, interacting with the database, and generating dynamic content to be rendered in the HTML templates. This is model file which contains algorithm information which will be loaded into the project code during runtime. This is notebook.ipynb file. This is a Jupyter notebook file which contains a combination of code, graphs, and outputs all in one place. It allows users to write and execute code in individual cells, making it a popular choice for data science. This is signup.db file. This file is the database file used to store user information. First, we need to copy the path of the code folder from the address bar of the file explorer. Here, I'm copying the path. Now, open the Anaconda prompt. Use the cd command followed by a space and paste the copied path and hit enter. This command is used to change the current directory to the code folder's path. Compile the app.py file using the command python space app.py. So here I'm typing python space app.py and hit enter. This command will execute the Python script and perform a runtime check for any syntax errors or logical issues. After running the app.py file, the Flask framework will host the application locally at the default address. Which is this localhost, and port, which is this. Now copy this local link provided by the Flask framework. I'm copying the link and paste this copied link into any web browser. I usually prefer Google Chrome and hit enter. The homepage of the project is displayed in the browser. This is the front end built using Flask framework. If we are new users, we need to register first. So click on sign up link here. Here we need to enter all these details to register, but I have already registered myself. So click on sign in button. So here we need to enter the username and the password which we have registered, and then click on login button. We have logged in successfully. This is the medical chat bot, and this is the text box where we need to enter the symptom. And after entering the symptom, the application will predict the disease and will give us the required diet plan, and the doctor will recommend the drug. Here in the notepad, we are having some of the symptoms name. So I'm copying the first symptom and paste this copied symptom in the text box and then click on predict disease. So here we can see the symptom, which is itching skin, and it is predicted as chronic cholestasis. And here we can see the required diet plan, the foods which we are supposed to take, and the food which we are supposed to avoid. And here we can see the doctor name, and this is the drug recommended by the doctor. Let us enter some more symptoms. And now click on predict disease. So this is the symptom, which is rash nodal, and disease predicted as fungal infection. This is the diet for the fungal infection, the things which we are supposed to do. And here we can see the doctor name, and these are the drugs recommended by the doctor. Let us enter some more symptoms. Now click on predict disease. So here we can see the symptom name, which is vomiting yellowish skin, and it is predicted as chronic cholestasis. And here we have the complete dietary plan. foods to eat and foods to avoid. And here we have the doctor name, and this is the drug recommended by the doctor. Let us enter some more symptoms. Click on predict disease. So here, this is the symptom: nausea, loss of appetite. Disease predicted as hepatitis C. And here we can see the complete dietary plan. And these are the foods which are supposed to be avoided. And here we can see the doctor name. And these are the drugs recommended by the doctor. In this way, by entering the symptoms, we can get personalized dietary plans and drug recommendations. Now click on logout link here. Conclusion: the disease and drug recommendation system represents a significant advancement in healthcare decision making by leveraging machine learning and deep learning techniques. These technologies enable the system to analyze vast amounts of healthcare data and extract valuable insights to aid in decision making processes. Through the utilization of advanced algorithms such as random forest, k-nearest neighbor, support vector machine, and CNN, the system provides healthcare professionals with personalized recommendations for disease diagnosis and drug selection. By considering various factors such as patient medical history, symptoms, and genetic information, the system offers tailored treatment plans that are optimized for individual patients. The implementation of this innovative system holds promise for enhancing patient outcomes by ensuring that treatment plans are both informed and personalized. By leveraging the insights and recommendations provided by the system, healthcare professionals can make more accurate and effective decisions, ultimately leading to improved patient care and outcomes. Future research and development efforts can focus on further refining the system's capabilities and expanding its deployment in real world healthcare contexts. This includes exploring additional algorithms, improving the system's scalability and usability, and integrating it into existing healthcare infrastructure. By advancing the disease and drug recommendation system, we can drive the evolution of personalized medicine and healthcare delivery, ultimately benefiting patients and healthcare providers alike.
Thank you for watching video. For more projects, please visit our website www.trueprojects.in. For updates on latest project videos, please visit True Projects YouTube channel and subscribe.